Hi everyone, welcome to today's tutorial. So we're looking at the types of roots in this tutorial, and before we can start, make sure that you subscribe to the channel if you have not yet done that, and click on this notification button immediately after clicking on the subscription button. Then after that, you can see to it that if you have any questions, you send them over, that I help you. Yeah, so I'm going to be helping you not only in mathematics but also physics. So make sure that you send your questions on WhatsApp, and make sure that you subscribe to the channel. If you have any questions, send them over on WhatsApp or Telegram, or just give me a direct call. Alright, so let's continue solving this question. So the question says, the equation 7x squared plus 2kx plus k squared is equal to k plus 7, where k is a constant, has two real roots. Show that k satisfies the inequality, this one there, and find the range of possible values of k. So this one is simple and straightforward. So the first thing that I'm going to talk about are the types of roots. So you need to know the types of roots before you start solving such a question. So the first type of root that we're going to look at is what are called the first types, what are called the two, we have the first type of roots. We have two real roots. So roots are simply just the answers that you get after solving an equation. Yeah, so more especially a quadratic equation or a polynomial going up. Any equation that has a degree that is above 2. Yeah, so the answers that you get are normally called roots. So in this case, we're dealing with quadratic roots. That's what we're talking about. That's why we're talking about two real different roots. So we say two real different or two real distinct roots. That's what we say. Two real distinct or different roots. Some books they say unequal roots. Unequal roots. Yeah, so this is how these are the first types of roots that we have. The second ones that we have are simply just equal roots. We have equal roots. So we have what are known as equal roots. So for two real different roots, let me first finish equal roots. For two real different roots, this is a situation where if after solving the quadratic equation you find maybe x is equal to 2 and x is equal to 5, you have two answers that are different, and these answers are real roots. And then for equal roots, I'm sure you've solved a quadratic equation before which has given you maybe x is equal to 2 and x is also equal to 2. It means that the roots of that quadratic equation are equal roots. And then you also have the third type of roots, which are complex roots. So if a quadratic equation has complex roots, it means that they can that particular equation can't be solved using factorization method, and hence if you solve that equation using the formula method, which is just negative b plus or minus the square root of b squared minus 4ac over 2a, you discover that the answer that you are going to get is going to be a complex number. Yeah, the answers that you get are going to be complex number, and you can only have complex numbers when what is down here, when what is under the root there, which is b squared minus 4ac, is less than 0. So when you get a negative answer there, it means that the square root of a negative number, we know to say the square root of negative 1 is simply just equal to I, yeah, according to complex numbers. So if you have the square root of negative 25, the answer will simply just be 5i. So 5i is the square root of negative 25. So whenever you get a negative answer there, it means that you have a complex number. Yeah, so the answer will be a complex number. Hence the type of roots that quadratic equation has is simply just complex roots or imaginary roots. In some books they call them imaginary roots, because complex numbers are also known as imaginary numbers. Alright, so here what we have discovered is that for you to have complex roots, it means that what is under the square root there is less than 0, meaning it's a negative number. So from this we can conclude now to say whenever b squared minus 4ac is less than 0, it means that the equation has complex roots. And then if at all b squared minus 4ac is greater than 0, it means that the equation has two real distinct roots or different roots. And then if b squared minus 4ac is equal to 0, it means that the equation has equal roots. So it is very important to know these three statements that I've written on the screen. Okay, so let us quickly move on we solve this equation. So they are saying this equation has two real roots. So if it has two real roots, it means that the given equation, if it has two real roots, it means that the given equation has two real roots, meaning it has two real roots, meaning the discriminant, this part, the one that we are calling b squared minus 4ac, this one is called the discriminant, and it's denoted by d. So when we say this is less than 0, we can also just say d is less than 0. Here we can say d is greater than 0. Here we can say d is equal to 0. So the discriminant, when the discriminant is less than 0, it has complex roots. When the discriminant is greater than 0, it means that the equation that we've been given has two real distinct roots. And then if the discriminant is equal to 0, it means that the given equation has equal roots. Alright, so let's solve this equation now. So this equation that you are seeing here, we've been taught that it has two real roots. So if it has two real roots, it means that the discriminant of this given equation is actually greater than 0. So b squared minus 4ac in this equation is actually greater than 0. So when the discriminant is greater than 0, then b squared minus 4ac is greater than 0. So let us identify which one is our a, b, and c in this given equation. So I'm going to write this equation down here, which is just going to be 7x squared. Okay, let me just write it properly. So we're saying d is greater than 0. So we write this equation 7x squared plus 2kx plus k squared is equal to k plus 7. So we arrange this in we rearrange this to a format of a quadratic equation, which is just ax squared plus bx plus c is equal to 0. So we arrange everything, meaning we're taking these terms to the other side of the equal sign. Okay, so let us do that. We have 7x squared plus 2kx, then plus k squared. Then we take this to the other side of the equal sign. We're going to have minus k, and then we have minus 7, of course. And then we say this is equal to 0. So the first question is that show that k satisfies inequality, this one there. And how do we show that? Let us quickly do it here. So the discriminant is greater than 0. So when we say the discriminant is greater than 0, we can identify which one is our a, which one is our b, which one is our c in this equation. So our a is simply just equal to 7, our b is simply just going to be equal to 2k, and then our c will be equal to k squared minus k minus 7. So now let us replace them in this equation, which we know to say b squared minus 4ac is greater than 0. We replace this into this equation, greater than 0. So let us do the replacement there. So our b squared, our b is simply just this part here. So we have 2k. Yeah, so we have 2k, then we square this, then minus 4. Our a is simply just 7, and then our 4a, and then our c is k squared minus k minus 7. This is what we have. So we're saying this is greater than 0. So let us simplify this. So simplifying this, we're going to get 4k, 2k squared, this will be 4k squared. Then 4 times 7, this is going to be 28. So 28, this is negative 28. So negative 28 times k squared, we're getting negative, so negative 28 minus times k squared, we're getting negative 28 k squared. Then negative 28 times negative k, we're getting positive 28 k squared. And then negative 28 times 7. So this is just the same as 49 times 4. Alright, so this is just positive 196. So we're saying this is greater than 0. So from there, we can now simplify the expression. So 4k squared minus 28 squared, this one is giving us 24, negative 24k squared. And then when we take this, I mean, we can just write this remaining part. We have 28k squared plus 196 is equal to 0. So from there, what we can do now is we can find the number that can go into 24, 28, and 196. And I believe this can be, or rather, there's supposed to be a greater than symbol here, not an equal sign. So we can divide by everything by 4. So when you say negative 24 divided by 4, this will be negative 6k squared. And then into 28, this will be positive 7k. And then we have positive, when we divide into that, we're going to have 4 into 19, that is 4. Remainder 4 into 19, that is 4, remainder 3. 4 into 36, that is 9. So we're saying this is greater than 0. So we can see that we have a negative in front there. We can divide everything by negative 1, negative 1, negative 1, negative 1. So when we divide negative 6 by negative 1, this will give us 6k squared. When you divide that, we're getting negative 7k. When you divide that, negative 49. And then when you divide any number, rather when you are dividing an inequality by a negative number, the sign changes there. So the sign will face this side to become less than 0. So we have proved that k satisfies this inequality because we have managed to find the inequality. So this is exactly how you do or how you solve such equations. Alright, so since we have done that, let us now move on to the second part. You can see that this one is equal to that. So let us now move on to the second part where we're going to find the range of possible values of k. So this part is also going to be, is also simple and straightforward. So finding the range of values of k, we simply just solve this same inequality. So the inequality is 6k squared minus 7k minus 49 less than 0. So solving this inequality is simple. We can first find the factors, or if not finding the factors, and but the best way we can do this, if we want to do it quickly, you can use the formula method. The formula method at least maybe can be easier, but you can also use factorization method. We can also try to use factorization method. So 6 times 49 to find the product. So the product will be equal to 6 times 49. So when you multiply 6 and 49, you get 294. And then this is the product, and then the sum is simply just negative 7. So this one is also negative because this is negative 49. When you multiply them, you're getting negative 294. So let me just write this properly. Okay, so negative 294. So there are two numbers that we can multiply to give us 294. Then when we add those numbers, they are giving us negative 7. Alright, so these numbers are simply just negative. These two numbers, when we multiply them, we're getting negative 294. When we add them, we're getting negative 7. So we have negative, so factors are simply just going to be equal to negative 21 and 14. When you add these two, you are getting negative 7. When you multiply these two numbers, you are getting 294. So let us replace them there. So we have 6k squared, then we have negative 21k, positive 14k, then we have negative 49 less 0. So from there we can now solve this quadratic equation. We can factorize. So the common factor there, we have 3k. 3k can go into 6k squared and 21k. So 3k into 6k squared, we have 2k. 3k into 21, we have negative 3k into negative 21, we have negative 7. Then the other number that can go into 14 and 49 is simply just 7. So we can write our 7 there. Then open brackets, we have 2k. Then into 49 there we have 7. So we say this is less than 0. So we can put the common factor, which is 2k minus 7. Then we also get 3k plus 7. Okay, so we have this is less than 0. So we say to find the oasis, the critical points, we're going to say let 2k minus 7 and 3k plus 7 be equal to 0. So when we equate that to 0, we're going to have 2k minus 7 is equal to 0 and 3k plus 7 is equal to 0. So from there we'll find the values of k. So the first value of k that we're going to have is simply just going to be found by taking this negative 7 to the other side to be 7 divided by 2 to be 7 over 2. And then here we're going to have 3k is equal to negative 7 over 3. Yeah, so this is the value of k, not 3k. After solving for k, you get negative 7 over 3. So these are the numbers that we have. So what we're going to do, these are not the final answers, these are just called critical points. We're just using them to test, to find the range of the possible range of values of k. So these are just called critical points. Alright, so let's put these on the real line where we're going to test them to find the final answer now. So we're going to put our negative 7 over 3 there and our 7 over 2 there. So this range is simply just k. This range is k less than negative 7 over 3. Then here we're going to have negative 7 over 3 less than k less than 7 over 2. And then this side we have all the values of k which are greater than 7 over 2. So let's try to test any two numbers, rather any number that is less than negative 7 over 3, meaning the numbers that are this side. Any number that is less than negative 7 over 3, we can get negative 4. So when we put negative 4 in this expression, let us use this expression to test. When we put negative 4 where there is k there, so we're going to have 2 times negative 4, which will give us negative 8. So negative 8 minus 7, that will give us negative 15. So I'm just going to write a negative, I'm just going to write the sign there. The answer that I've gotten here is a negative, so I'm just going to write a negative. So when I put the same negative 4 there, I'm going to have negative 12 plus 7, that will give me negative 5. So I'll put a negative there. So negative times negative is positive. So is a positive number less than 0? There's a less than symbol here. Is a positive number less than 0? The answer is no. So we cancel this part. We move on to this middle part. We ask ourselves, we get any number that is between negative 7 over 3 and 7 over 2. So I like using 0 because between a positive and a negative number, 0 is always there. So when I get 0, I replace it there. I'm going to have 0 minus 7, I'm going to get a negative number. And 0, when I put there 0 times 3, that's 0. 0 plus 7, that will be a positive number. So negative times positive, the answer is negative. Is a negative number less than 0? The answer is yes. So this region qualifies. We get any number that is greater than 7 over 2. We can get 5, because 7 over 2 is simply just the same as 3. Yeah, we can get this is just the same as 3 point something, 3.5. Yeah, so when we divide this is just the same as 3.5. So we can even get 4 or 5. So if we get a number greater than 7 over 2, we can even get 5. Okay, we put 5 there. So we're going to have 2 times 5, the answer will be 10. 10 minus 7, that will be 3, and it will be a positive number. So I'm going to have a positive there. So if I put 5 there, I'm going to have 3 times 5, that is 15 plus 7, that is 22, which is also a positive number. So positive times positive, we're getting a positive. So is a positive number less than 0? The answer is no. So this part is also disqualified. So the range of values of k that are needed, or that they want us to find, is simply just from negative 7 over 3 to 7 over 2. Hence you can write this in set build and in interval notation rather, as k is equal to negative 7 over 3. Let me write it properly. Negative 7 over 3, comma 7 over 2. So we can write it like that. So this is the final answer. Or you can just say the range of values of k, simply this, you write this. Alright, so this is exactly how you solve such a question. So make sure that you don't forget to subscribe to the channel, and if you have any questions, feel free to ask to contact me on any of these numbers on the screen, and click the notification button. Let's look at the other question. So this other question is also similar to the previous question from solving, so I'm just going to do it very quickly. So they're saying the equation, this one, where k is a constant, has no real root, meaning it has complex roots. So if it has complex roots, it means that it has no real roots. So they are saying show that k satisfies the inequality k squared minus 6k plus 4 greater than 0, and find the exact range of possible values of k. So we do the same procedure. So the first thing we identify which one is our a, b, and c from this equation. So our a is simply just going to be equal to the coefficient of x squared there, which is k minus 4. Then our b is negative 4. Then our c is k minus 2. So we are going to use the discriminant. They are saying it has no real root, meaning the discriminant is less than 0. So if the discriminant is less than 0, this simply means that b squared minus 4ac is less than 0. So we can replace the value of a, b, and c in this expression. So the value of b there is negative 4. So we're going to say negative 4 squared minus 4. Our value of a is k minus 4. And then our value of c is k minus 2. Then we're saying this is less than 0. So we're getting this to be 16 there. Negative 4 squared is 16. And then we have negative 4 outside. We multiply these two. So when we multiply these two, we're going to get k squared, negative 2k, and then negative 4k. And then we have positive 8. So we are saying this is less than 0. So we are going to have negative 4k squared when you simplify this. So negative 2 and negative 4 give you negative 6 times 4. We're getting negative 24 k. And then we're getting, and then here we have 8 times 4 there. We're getting negative 32 less than 0. So from there we can now simplify this expression, or we can just rearrange it, or we add 16 and 32 there. So we are going to have negative 4k squared, then negative 4k squared, okay, negative k squared and then negative 24k, negative 24k, and then when you add 16 and negative 32, you're getting negative 16 is less than 0. So to simplify this, we're going to divide by negative 4. Negative 4, negative 4, negative 4, negative 4. So here we're remaining with k squared. There we have positive, we're going to have positive 6k, and then there we have positive positive 4. Then we have this side, since we're dividing by a negative number, the sign will change, and then this will be 0. Okay, there was a mistake here. We were supposed to say negative 4 times negative 6, which gave us, it was supposed to give us positive 24. So this one is supposed to be positive 24. Then okay, so then when we divide that, this should be, this should give us a negative 6k. Yeah, so this is what is supposed to be done. Alright, so from there, what we're supposed to do is we simplify this expression. I mean, we've managed to show that k satisfies this inequality according to what they wanted. So we've managed to do that. So the only thing that is remaining is to find the exact range of possible values of k. So I've done that. So what we're going to do is to solve this quadratic equation. So solving this, the quadratic equation is simply just k squared minus 6k then plus 4 is greater than 0. So this is what we have. Okay, let me just write it properly. We have k squared minus 4 minus 6 rather, 6k plus 4 greater than 0. Okay, so this is what we have, and then we have been taught to solve this. So we're going to find the factors. The product, first of all, simply just found by multiplying the coefficient of k squared and 4 there, which will just be which is just the same as when we multiply the coefficient of k squared there, which is 1 times positive 4 there, we're getting 4. Then the sum is simply just negative 6. Then once you do that, you find the factors. So two numbers that we can multiply to give us 4, when we add those two numbers, they will give us 6. They'll give us negative 6. So I'm sure these numbers, maybe we can yeah, I'm sure these numbers may be 1 and 5. So 1 and 5, which one is going to be negative? They will both be negatives. So we have negative 1 and negative 5. So when you add negative 1 and negative 5, we're getting negative 6. When you multiply them, you're getting, oh no, this one will not work out. So when you add them, you're getting negative 6, but when you multiply them, you're not getting 4. So let's just use the formula method. So let's just use the formula method to solve this quadratic equation. Okay. So the formula method, according to the formula method, we know that this will be equal to, k is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So the value of k will therefore be equal to b, negative b, there's that negative and that negative, they'll cancel, so we'll just have 6 plus or minus the square root of b squared, this will be negative 6 squared minus 4. A value of a is 1, and then the value of c is 4. Then everything divided by 2a, our value of a is 1. So the value of k is simply just going to be equal to 6 plus or minus. This will give us 36 minus 6 squared is 36 minus 16. That will just give us 20. Then everything divided by 2. So from there, we have this. Yeah, we have these are the values of k. So the first value of k that we have is we can simplify this. So 20 can also be written as I mean the square root of 20 can also be written as the square root of 5 times 4. So this can also be written as square root of 4 times the square root of 5. So this would be 2 root 5. So 20 can be written as 2 root 5. Okay, so we can write this as 6 plus or minus 2 root 5, then everything divided by 2. So when we simplify this, this can also be written as 2 into 6 there, we're getting 3, plus or minus 2 into 2 root 5, this is just root 5. So we can have the first value of k as 3 plus root 5, and then the second value of k is 3 minus the root of 5. So now we can put this on the number line. So we have 3 minus the root of 5, then we have 3 plus the root of 5. So this side we have all values of k less than 3 minus the root of 5. Then here we have 3 minus the root of 5 less than k, then less than 3 plus the root of 5. Then here we have all values of k greater than 3 plus the root of 5. So we can test any number that is any number that is less than 3 minus the root of 5. We can test any number that is less than 3 minus the root of 5. We can even use this same quadratic formula there. So we can test that number. Let's say maybe we test, okay, 3 minus the root of 5. The root of 5 is simply just 2 point something. So the root of 5 is simply the same as simply the same as 2 point something. So we can even get any number that is less than that. We can even get a 0. So the root of 5 is 2 point something. So when we say 3 minus 2.2 something, 2.24 somewhere there, yeah, so if we say 3 minus 2.2 something, we're getting 0 point something, and then the number that is slightly less than that, we can even get a 0. So when we test this equation, we put a 0 there, put a 0 there, we're going to have 0 minus 0 plus 4 is 4. Is 4 going to be less? Is 4 greater than 0? The answer is yes, meaning this part qualifies. We can get any number between the number that I just found, which is the root of 5, which is 2.2. We say 3 minus 2.2, that is about 0.8. So I'm just making approximations of these numbers. So any number between 0.8 and 3 plus the root of 5, which is 3 plus 2 point something, which is about 5. So any number between 0.8 and 5 is we can even get 3 or 4. So we can get 3. So I'm going to get 3. So we put 3 there. When we put 3 there, we're going to have 3 squared, that would be 9 minus 3 times 8, 3 times 6, that is 18, then plus 4. So when we say 9 minus 18, this is negative 9. Negative 9 plus 4, that is going to be negative 5. Negative 5, is it greater than 0? The answer is no. So meaning this region is disqualified. So let's quickly get any number that is greater than 3 plus the root of 5, which is just about 5 point something. So we can get even 7. So let's try to put 7 there. So we put 7 while there's k there. So when we put 7, we're going to have, so when you put 7 there, we're going to have 7 squared, which is 49. 49 minus 6 times 7. So 6 times 7 is about 42. So say 49 minus 42 plus 4. So this will be a positive number, of course, and we know that all positive numbers are greater than 0. So this region also qualifies. So the range of values of k that are needed in this case are simply just k less than 3 minus the root of 5 and k greater than 3 plus the root of 5. These are the ranges of values of k that are needed. So if you want, you can write this in set builder notation, in interval notation rather, as from negative infinity up to 3 minus root 5, comma, I mean not really comma, but we close the bracket there and then you say union from 3 plus the root of 5 to positive infinity. So this is what you can write. So these are the ranges of values of k that are needed in this question. Alright, so let's check if there's another question that is similar. Okay, we have a straight line with equation. This one does not cross or touch the curve with the equation y is equal to that, where p is a constant. The question is, show that 4p squared minus 20p plus 9 is less than 0. Okay, so they are saying the straight line, this one, the straight line with equation, this one, does not cross or touch the curve with the equation, this one, where p is a constant. Show that 4p squared. So if they say this equation does not meet this quadratic equation does not meet this line here, it means that the given equation, or the given rather the roots, or the type of roots, when this equation is equated to that, the type of roots that you are going to have is simply just if they do not touch. I didn't talk about this, but let me talk about it. If an equation has two real different roots, it means that the discriminant is greater than 0, and whenever the discriminant is greater than 0, it means that when you sketch that given quadratic equation is going to meet the x-axis at two different points. This is what it means. This is why, because when you solve this quadratic equation which has two real different roots, you're going to find two answers. X is equal to alpha and another x is equal to beta. So you have your alpha there and your beta there. This is what it means. So when the equation has equal roots, when it has equal roots, when the discriminant is equal to 0, it means that it meets the curve. It meets the curve at only one point. So this is the case where you find the first value of x is equal to alpha and the second value of x is also alpha. So meaning at this point, at this answer that you found, if this is 2, if this alpha is 2, maybe if you have x is equal to 2 and another x is equal to 2, it means that this point where it's meeting the x-axis is equal to 2. So if it has no real roots, it means that it doesn't meet the x-axis at any point, meaning it's like this, or like that, or like that, or like that, or it can be there or there, but it will not cross the x-axis at any point. So the reason why we put a 0 this side, it means that we are representing, this 0 represents this line here. The line where y is equal to 0 is simply just the x-axis here. And that's what it means. So if we put an equation this side, if we put an equation this side, if we put an equation while there's 0 there, it means that we are talking about any line. It can be any line in the x or y plane. So what that means is that while there is y, if this equation, while there is y, we put y there. So we're going to have 3x minus 7 is equal to 2p 2px squared minus 6px plus 4p. We simplify this equation. So when you simplify this equation, we are going to have we put the like terms together, meaning we're going to have 2px squared, then 3x and 6px are going to be together, hence we'll have negative 6px. When this crosses the equal sign, we are going to have negative 3x, then we have positive 4p there, and then positive 4p plus 7 is equal to 0. So from this equation, we can identify which one is our A, B, and C. Or what we can do is simply we factorize it properly, we put it properly, so we can have 2px squared, and then we can have a plus there. And then from there, we can say open brackets, we have negative 6p minus 3, close the brackets, and we have x there. Then we have 4p plus 7 is equal to 0. So in this equation, remember we have to put these values in the formula, because they are saying that these two equations do not meet at any point. Hence the what is the equation has no real roots. So if it has no real roots, this simply means that it has no real solutions in this case. Yeah, so if it has no real solutions, it means that the discriminant is going to be less than 0, not greater than. It's going to be less than 0. So the discriminant is going to be less than 0. Okay. So meaning our b squared minus 4ac will be less than 0. So which one is our a? So our a is simply just going to be equal to 2p, and then our b will be negative 6 minus 3, negative 6p minus 3. Then our c will be 4p plus 7. So this is what we're going to have. So our b squared, when you say b squared, means that we're going to have negative 6p minus 3 squared, then minus 4, our a is 2p, then our c is 4p plus 7. So let us quickly simplify this equation. So we're saying this equation is less than 0. Let me just write that. Okay. Alright, so we're saying this is less than 0 because it has no real roots. So when we simplify this one, when you simplify this equation, we're going to have 36p squared, then we have positive, this will be 18, that will be again positive 36p, and then we have positive 9. Then we have minus, when you just simplify this part, and then this minus, and then we have 4 times 2p, we're going to get 8p. So 8p times, so this is 8p times 4p, this will give us negative 8p times 4p, this will give us negative 32p squared. Then we also have negative 8p times 7 there. So 8 times 7 is simply just 56. So this one will give us negative 56p. Then we're saying this is less than 0. So we're still simplifying. Okay. So let us pair the like terms. So when you pair this one, 36 and negative 36p squared and negative 32p squared, we're going to have 4p squared, Then the other part that we can add is the part of 56 and 36. When you add this negative 56 and 36, they are getting negative 20p, and then we have positive 9 there, positive 9 less than 0. So we can see that we have managed to show that this equation is equal to that. And then they're asking us to say, hence find the set of values of p. Yeah, the set of values of p. So we can also find the same thing. We find the product. The product is 4 times 9 there, which is 36. Then the sum is simply just negative 20. So we find the factors now. So the factors, numbers that we multiply to get 36, and then when you add, we get 20. So these numbers can be 2 and 18. Of course, one should be negative there. So 2 and I think both should be negative. So negative 2 and negative 18. When we multiply this, we're getting negative 36. And then when we add them, we're getting negative 20. So we plug them into that equation. So we have 4p squared, then negative 2p, then negative 18p, and then what else? We have positive 9. We have, this is less than 0. So from there we can say 2p open brackets. Into that we're getting 2p, then into that we're getting negative 1, close the brackets. Then the common here is 9. Of course the negative is in front of 18, so to also be common, so say negative 9 is common, which will give us 2p negative 1 less than 0. So we have 2p negative 1, then we also have 2p negative 9 less than 0. So to find the critical points, we're going to say let, so this one is a less than symbol. Say let 2p minus 1 and 2p minus 9 be equal to 0. So what this means is that our 2p minus 1 is equal to 0, then 2p minus 9 is also equal to 0. So meaning the value of p will now be equal to 1 over 2, the other value of p will now be equal to 9 over 2. So we can test these points on the number line. So we have 1 over 2 there and 9 over 2. So all these values of p this side, they are less than 1 over 2. Then here we have values that are between 1 over 2 and 9 over 2. This side, all the value of p are greater than 9 over 2. So we can test any number that is less than 1 over 2. Can even get a 0. So we will test them in this equation there. So 0, when you put 0 as p there, we're going to have 2 times 0, that is 0. 0 minus 1, that will be negative 1. So I have a negative there, then negative 1, yeah, we have negative 1. So even here we put a 0 there, we're going to have negative 9, which is, I'm going to write a negative there. Negative times negative, we're getting a positive. And then we move on to the second part here. So when we test any number that is between half and 9 over 2, so 9 over 2 is simply just 4.5. Yeah, so 4.5, between 0.5 and 4.5, we can even get 3. So we can test 3 there. When we put 3 there, we're going to have 2 times 3, the answer is 6, minus 1, the answer is 5. So 5 is a positive number, and then we can put the 3 there as well. So 3 times 2, that is 6. 6 minus 9, the answer is negative. So negative 3. So negative times positive, the answer is negative. So we can also test any number that is greater than 9 over 2. We can even get a 5. So 5 times 2, the answer is 10. 10 minus 1, the answer is 9. So that is a positive 9. Then you get a number that is, the same number 10, we test it there. So 10 minus 9, the answer, we get the same number there, which is, we've got 5. 5, which is 5 times 2, we get 10. 10 minus 1, the answer, 10 minus 9, the answer is 1. Which is also positive. Positive times positive, we get a positive. So we start checking up now. So is a positive number less than 0? The answer is no. So this one is not part of our answer. Is a negative number less than 0? The answer is yes. Is a positive number less than 0? The answer is no. So these two regions have been denied, meaning the range of values of p that we are needed to write or to find are simply just 1 over 2 less than p less than 9 over 2. So this is the range of values of p. If you pick any number between 1 over 2 and 9 over 2, you plug them where there's p there, you discover that the answer that you get after solving together with that, the roots that you get, or the answer that you get, the roots that you get will be complex roots because these two equations do not meet. Alright, so let's quickly check if there's another question on the types of roots. If there's no question, then we end the meeting. Alright, so this was the last question on the types of roots. So if you have not yet subscribed to the channel, make sure that you do so by simply just clicking on the button, on the subscription button, and also hit the notification button there so that you don't miss the videos that I'll be posting. And if you have any questions, feel free to contact me on any of these lines on the screen. Thank you very much for watching the tutorial. My name is Harmtedy. Shalom.